Welcome to lesson 2.7 over proving segment relationships. All right, we'll get started right away. In the past, we've written algebraic proofs and two-column proofs. We're going to use more of that and write proofs that involve segment addition and then also segment congruence today. And so we're just doing some more proofs. There's very little vocabulary you have to write down. In fact, there aren't any individual vocab terms. There's a postulate and a theorem that has three parts to it that you'll need to write in your vocab book for lesson 2.7. We have another postulate to add to our previous list, and this is something we talked about back in chapter 1, but we do officially have what's called the segment addition postulate. You talked about the betweenness of points back in chapter 1. It gives you the same relationship, and in proofs we call that the segment addition postulate. All right, and that just says AB plus BC equals AC. And then we have our theorem 2.2, properties of segment congruence. You'll recognize these properties as properties of equality also, but they do have property of congruence counterparts. We have the reflexive property of congruence, the symmetric property of congruence, and transitive property of congruence. Once again, property of congruence we can call POC instead of POE for property of equality. So every one of these has a congruent symbol. Reflexive property looks the same. Symmetric is just when you flip it around. And then the transitive property is one we will use quite often, but it's the property of congruence. Okay, and this is the proof of that transitive property. And so we can use that since AB and CD are congruent and CD and EF are congruent, their lengths are equal by definition of congruence. And then by the transitive property of equality, we can say that AB equals EF, and by definition, AB is congruent to EF again. So we will use that property quite often in our proofs. Let's take a look at example 1. We are given AB is congruent to CD. They give you the diagram. You need to make sure you mark that on the diagram. We want to then prove that AC is congruent to BD. Now notice these both share segment BC. Well, if these two are congruent, they have the equal measure, and they both share this. So when I use segment addition postulate, I'm adding BC to both of these to get those totals. So we should be able to eventually see AC equals BD. And so let's look at the proof statements and reasons for that. We always want to start off with our given information. We're given AB is congruent to CD. Now that tells me that those values are equal by definition of congruent segments. Now notice that AC shares BC with BD. They both include segment BC. Well, if we have our segment addition postulate, I can actually add these two together to get the full segment and these two together to get the full segment. So what I can do in this equation is actually just take BC and add that to both sides of this equation by the addition property of equality. AB plus BC equals CD plus BC because we added the same value to both sides. Now, we know these are equal, so that's how we can get this by the segment addition postulate. AB plus BC equals AC, and CD plus BC equals BD. Now, since they both have been set up like this, AB plus BC is equal to AC. So I can replace AB plus BC with AC, and CD plus BC is equal to BD, so I can replace that side with BD. So if I substitute just AC in for that one and BD in for that one, we get AC equals BD in length. And we're trying to prove that they are congruent, so by definition of congruent segments, they are in fact congruent. All right, let's take a look at example 2. Here we're given GD is congruent to BC, and these don't have to look like they are. We're given that they are in fact congruent. We know BC is congruent to FH. GD is congruent to BC, and that's congruent to FH. Now FH is congruent to AE. We want to prove that AE is congruent to GD. Now as I've marked them, they're all congruent. We just have to be able to line that up and show that in a proof. So let's take a look at what we should do first. Now, we usually start off by putting all the given in this first statement, but I want you to notice something. These first two givens, GD is congruent to BC and BC is congruent to FH, those can end up telling me that GD is congruent to FH by the transitive property. And so I only want to list those two first in this proof. I'm going to start with those. GD is congruent to BC and BC is congruent to FH. That's given. Sometimes we can split the given information up. We'll come back to this one later. But that immediately tells me that GD is congruent to FH by the transitive property of congruence. But we have this other given, so I'm going to include that next. FH is congruent to AE because it's given. And now, since GD is congruent to FH and FH is congruent to AE, we can say that GD is congruent to AE by the transitive property. And all we have to do to make it look like what we're trying to prove is to turn it around by the symmetric property of congruence. AE segment is congruent to segment GD. All right, one more proof to go. So let's take a look at what we're given in example 3. We are given AC is equal to AB. I don't want to mark them congruent. I'm just going to deal with their equality. AB is equal to BX, and CY is equal to XD. Now, these two smaller segments are not related to these bigger segments. We want to prove that AY equals BD. Alright, once again, we're going to focus on these first two given statements because you'll start to recognize this pattern. AC equals AB and AB equals BX. That means AC equals BX by the transitive property of equality, since we're talking about equal lengths. Now, we also were given CY equals XD, so let's state that next. Now, since these two are equal, I can take this equation and I can add CY to this side and XD to this side by the addition property of equality. Since these are both equal, I'm adding an equal value to both sides of that equation, so I can get AC plus CY equals BX plus XD by the addition property of equality. Well, AC plus CY also equals AY by the segment addition postulate, and BX plus XD equals BD by the segment addition postulate. AC, CY add up to AY, BX, XD add up to BD by the segment addition postulate. Well, since these are both equal, I can substitute AY in for this and BD in for that, and we get that AY equals BD by substitution. Alright, that wraps up our notes for lesson 2.7. We'll do a lot more proofs like this in class, but you should have a pretty good start on this next lesson.